Let us evaluate the integral of cosine to the power of 13 of x. When dealing with an integral of cosine and the exponent is an odd number, you would first need to factor out 1 cosine of x, which makes this the integral of cosine to the power of 12 of x multiplied by the factored out cosine of x and copy the rest, which is dx. And the next step would be to transform the remaining terms into their trigonometric identities. Know that sine squared of x plus cosine squared of x is equal to 1. Since we have here would be cosine, transpose sine squared of x to the other side, which makes this cosine squared of x be equal to 1 minus sine squared of x. What we need here is a cosine squared of x. Condensing this term, it would be cosine squared of x. 12 divided by 2 would be equal to 6. So it would be raised to the power of 6 and copy the rest. Now that we have this, we can now transform it. There are two ways in which we can advance in here. First would be to expand this one as it is, or secondly, it would be to simplify this first in order to have a much more simpler expansion. So let us do the second one, which is to simplify the sine x here. In this case, let u here be sine of x. And du right here would be the derivative of sine of x would be equal to cosine of x, and multiply this by dx since it is respect to x. When you are dealing with something like sine of y, it would be equal to cosine of y dy. And the last step in here would be to isolate dx. So which means transposing cosine of x to the other side, which makes this du over cosine of x. Now that we have this value, we can now substitute it into here, which makes this the integral of 1 minus sine squared of x here would be equal to u squared to the power of 6, and copy cosine of x, and dx right here would be equal to du over cosine of x. You can see here that cosine of x would cancel, which leaves you with du. And so we are left with this integral form. Now that we have this, the next step would be to expand this. We have a power of 6 of binomial. The formula for this would be a minus, since it is negative, b to the power of 6, wherein a here would be equal to 1. Let's just put it in here. And b here would be equal to u squared. The general formula expansion for this would be equal to 1a to the power of 6 plus, minus 6a, it will be descending by 1 power, which would be 5, and the b value would be ascending by 1 power, so just put b here, plus 15a to the power of 4 multiplied by b squared minus 20a cube b cube plus 15a squared b to the power of 4 minus 6a multiplied by b to the power of 5 plus 1b to the power of 6. Let me just explain it. Let me just explain how this formula has came to be. For the coefficients in here, this was based on the Pascal's triangle. And for the a value, you can see here that it is, or I mean the power is descending by 1. You can see here it would be 6, 5, 4, 3, 2, 1, and 0 here. And for the b value, it would be ascending by 1. So that is just a simple advice on how to memorize this mentally. Anyway, moving on. This would be our formula, and we will just plug our values in here. So our expanded value here would be equal to 1 multiplied by a. A here is 1. 1 to the power of 6 is 1, so it would be simply 1 minus 6 multiplied by a. It is only 1 again. B here is u squared, so it would be 6u squared plus 15. A here again is 1. B squared would be u squared to the power of 2, which is equal to u to the power of 4. (20) multiplied by a cube, which is 1, multiplied by b cube, which is u squared to the power of 3, which would be equal to u to the power of 6. And so on. So for this, b to the power of 4, which is u to the power of 8, minus 6 u to the power of 10 plus b to the power of 6 here is equal to u to the power of 12. And just copy du here. Now that we have our values in here, the next step would be to integrate this one by one via power rule. Starting with this, the integral of 1 of du would be simply u minus 6 multiplied by the integral of u squared would be u to the power of 3 over 3 plus 15 multiplied by the integral of this, which would be equal to u to the power of 5 over 5 minus 20 multiplied by the integral of this, which would be u to the power of 7 over 7, and multiply this by the integral of this, which is u to the power of 9 over 9 minus 6, multiply it again by the integral of this one, which is u to the power of 11 over 11, and the integral of u to the power of 12 would be equal to u to the power of 13 over 13, and add plus c every integral. The next step here would be to simplify this expression first. So this would be u minus 6 divided by 3 here would be equal to 2. U to the power of 3 plus 15 divided by 5 would be equal to 3. U to the power of 5 minus 20 over 7. This cannot be simplified further, so we can just put it as 20 over 7 multiplied by u to the power of 7 plus 15 divided by 9. We can reduce this to 5 over 3 u to the power of 9 minus 6 divided by 11 u to the power of 11. And for this one, we can rewrite this as 1 over 13 multiplied by u to the power of 13 plus c. And the last step for our final answer in here would be to just substitute all u values in here back into sine of x, thus making this equal to sine of x minus 2 sine cube of x plus 3 sine to the power of 5 of x minus 20 over 7 sine to the power of 7 of x plus 5 over 3 sine to the power of 9 of x minus 6 divided by 11 sine to the power of 11 of x plus 1 over 13 sine to the power of 13 of x plus c, thus making this your final answer for the integral of cosine to the power of 13 of x.